Introduction. Reverse engineering, often known as back engineering, is a technique for extracting design knowledge from software, equipment, aircraft, architectural structure, and other items. Reverse engineering frequently entails dismantling individual components of larger items. Reverse engineering is occasionally used by auto restoration specialists to reproduce the design of engine and auto body part for older vehicles. Without modifying the architecture of the car system, reverse engineering can bring a classic vehicle back to life and make it completely functioning. Objective. First is to learn and get more information about the reverse engineering and layer-based manufacturing for rapid prototyping, rapid tooling, and rapid manufacturing. To elaborate the materials and method that used in order to produce a product using rapid prototyping. To explain a few recommendations how to improve the use of rapid prototyping in industry. Lastly, to construct appropriate rapid prototype product by using one of the rapid prototyping and rapid tooling method. Scope. First is aim industry to get more exposed to reverse engineering technology. Second, list the procedure or method in handling reverse engineering. Third, simplify industry tasks for innovation in their product. Fourth, replace old way technique according the technology's improvement. And lastly, suggest a few recommendations to improve the usability of reverse engineering.
Hi, Assalamualaikum. My name is Muhammad Hafiz Salikin bin Azizi with metric number AN100129. So for this reverse engineering presentation, I will present parts, results and data calculation. So in this reverse engineering, we had learned how we scan products into the program or software. So in order to get the results, we're going to capture the products in a few different side and angles. We're going to have many elements. Alright. So in our project, in order to get the last product in our program program software, we had captured 51 different elements from different sides and different angles. And from this 51 element, and lastly, it combined together until we get the last results on the of the actual product. So each of these elements, including the last product results, have their own data and also properties. So from these 51 elements, we had selected 3 different types of elements that had been captured from different sides and different angles, and we shown the data and properties for for each of these elements. So 3 different elements that we had choose is element M1, element M18, and element M33. Okay, so the first one, I'm going to show you the data and the properties for the element M1. Alright, for next, this is the data or properties for the element M2. And then the next one is the data and properties for the element M33. And as you can see, in each of these elements, we also had conclude the picture of this element, so you can see how it be captured, from what side, from what angles it be captured by using the 3D scanner. So the last data collection that we're going to show to you is the data of the last product. Alright, after we finish scanning all those 51 different elements, we combine all those different elements into one until it becomes one single part, which, as you can see in the last table, right? The picture of on the last table showing the last product, the last result that we get, alright, the last prototype model that we get. So of course, like others element, this product also have its own data, which, as you can see on the video we shown to you. Those are the data for this actual product. So that's all for the data and results and data collections. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shahid bin Azhari. Matrix number CN190186. For the material and method, in reverse engineering, the equipment that are most important is 3D machine that are named ATOS 3D scanner. The ATOS 3D scanner was equipped with a higher speed scan with the detail resolution. The component or part like motor, turbine or the other part can be scanned by ATOS to get a three-dimensional measurement data and analysis. This machine provide various parts. The first one is ATOS capsule technology. This capsule was provide process stability automation. This was made from the aluminium investment casting. The precise manufacture monobody was ensure maximum stiffness and precise manufacturing result for manufacturing and production usage. The second one is triple scan technology. This machine was provide two camera to capture the object surface and record the precise figure pattern that projected onto the surface of the object. 3D surface of the object can generate by the capture visual beam camera on left and visual beam camera on right. Next is the blue light technology. The blue light technology are in ATOS 3D scanning are to interfering ambient light that can be filtered image acquisition. Due to the powerful light source, the measurement of the whole part can be complete in short time. Self-monitoring system. During operation, the sensor detect and compensate for change in the ambient environment. To ensure the quality of the measurement data, the sensor software continually monitor the calibration stage, transformation accuracy and environmental change and part motion. And the lastly is virtual measuring room software. In virtual simulation, the replica of model were used for the real measuring environment, which eliminate the need specific robot programming abilities. The robot movement are simulated and validated before done job. For method, step by step in scanning using ATOS 3D scanning. The part that we choose was the pump hand that picture below. This part has been chosen because of the fulfill the criteria that has a big one part and has a bright color. The part was stick with the stickers 3D for the whole surface of part. This is because to make sure during the scanning, the 3D scanning can get accurate, precise result. This sticker in function to make the picture that are scanned is not switch or separate when the scan the other angle and to get the whole part. Then The result can see in GOM Inspect. We need to open the GOM Inspect using the software to edit or remove the non-essential part. After finish remove the non-essential part, we paste on the incomplete object by click Operation Mesh Close Hole interactively to get the whole complete part were assembly. That's all.
Assalamualaikum, my name is Afizi Mustafa for discussion. The result and data we get by using GOM software, which is GOM Inspect is a software for analyzing 3D measured data for figure projection of the scanner, coordinate measurement machine and other measure system. Before starting 3D scanning, we must put sticker to our product. The sticker will be reference point to connect each other point. If we don't put the sticker, the 3D scanning cannot do a scanning. If a scanner has an error or cannot scanning, make sure the reference be detected at computer before do the next scanning. After finishing the scanning, we erase the defect part in 3D scanning view and do some finishing to it. This will determine that measurement taken with Atos optical 3D scanner are relatively resistant to outside influence and operator mistake. Even with significant change in parameter, none of the 7 observable characteristic has impact on form error or dimension accuracy more than 30 meter. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Syarullah bin Sadir Rahman, matrix number CN190040. I will talk about the conclusion. So, reverse engineering is important for the continued operation of today's production system as technology develops and advances. Without reverse engineering, business would be compelled to replace complete computers on a regular basis, wasting a lot of money. Products that function and components that fail may be recreated via reverse engineering, regardless of how old the product is or whether the original producer is still in business. In manufacturing and engineering, reverse engineering is utilized for a number of purposes. It may assist a company evaluate and optimize manufacturing processes, increase product efficiency, and defend patents by dismantling engineering equipment or a produced product and finding the materials it is comprised of and how it operates. When the original technical drawing and material information are no longer available, or the original manufacturer is no longer in business, the produce is also used to figure out how outdated component or product work. For the recommendation, upgrading from an existing product is necessitate a true grasp of the previous version, and no matter how good the current product is, there is always space for development and growth. Component wearing out due to wear and tear, equipment not performing as it should after a period of time, and outdated technology that does not meet contemporary criteria are all examples of areas that should be improved. When it comes to product development, no matter what business you are in, there is always a space for improvement. Company might break down during production and become difficult to replace. OEMs can reproduce parts or make component prints for future design through reverse engineering if the original drawing become unavailable. Take the time to study and master them. There is a lot to learn and you probably won't have all of it right now. There is no need to be concerned. Make a goal to become an expert in this topic by devoting 1 or 2 hours every day to purposeful learning.